All right, so we're taking a look at the next section where we're solving trigonometric equations. So the main difference is that the expressions that we saw yesterday now have an equal sign. So those expressions are now equal to another expression, and now we're solving for the angles. So because we are now looking at equations, all those restrictions that we had before when we were simplifying, they don't apply here. Now you'll see that we want all solutions from 0 to 360 or all solutions from 0 to 2 pi. So all the angles around one full rotation around the unit circle is what we're looking for here. So we're going to have multiple solutions to these equations. Okay, and some tips and hints for solving here. If you see one trig function, we want to isolate it and then solve. If you see more than one trig function, we want to rearrange it so that the equation equals 0, and then we can factor. We can factor out a GCF, or we can factor normally, like what multiplies to C and adds to B, that sort of thing. Or we might need to try to use our identities to change the form of the equation, and what we might need to do is square both sides to change the equation. Now, if we manipulate the original equation at all, we just need to make sure at the end we check for any extraneous solutions. So these 3 tips and hints will come back to you. You'll see examples of all of them. But the big thing we're going to utilize here is that in order to solve for the variable, and we'll do just a basic one here. So sine of x equals 1, let's say. If we want to isolate this variable, we need to get rid of the sign, right? So what we're going to use is the inverse sign, and we're going to take the inverse sign of both sides. Why does that help? Well, if we take the inverse sign, then what happens is these undo each other, right? Just like adding and subtracting undo each other, or multiplying and dividing undo each other, the inverse sign of the sign would undo each other, and all we would be left with is x. And then x would equal the inverse sign of 1. And this is what we were used to seeing the past couple of days with the inverse expressions. And so now we're asking ourselves, what angle, right? What angle would give us a sine value of 1? And for this one, we would say that would be 90 degrees, right? So this whole taking the inverse of both sides is how we're going to actually isolate the trig function. And we'll see that right here in this first example, number 1. So we want to solve for the angle theta, which means first we need to isolate the sine of theta. So we're going to add 1 to both sides. We'll divide by 2, so we get sine of theta equals 1/2. So now that we've isolated the trig function, now we're going to take our steps to solve for theta. So this is where we're going to say, okay, well then the angle is the inverse sine of 1/2. So I didn't write it out, but in our minds, and we took the inverse sine of both sides, and said if sine of theta is 1/2, then theta is the inverse sine of 1/2, right? So we went from this form to isolating the angle, okay? And so now we can solve for theta. What angles give us a sine value of positive 1/2? A sine value of positive 1/2, and notice the interval from 0 to 360, so they want our angle values in degrees. That would be a 30-degree angle and a 150-degree angle. Again, the restrictions don't apply here because they're telling us in the directions that we want all solutions to solve the equation. Okay, let's try number 2. So here we have more than one trig function. So here we're going to look at this this tip number 2. If there's more than one trig function, let's rearrange the equation and then try to factor. So here, what if I subtract sine from both sides? So sine of x, tangent of x, minus sine of x equals 0. So now it's set equal to 0, and we can factor by taking out our GCF. So if we take out a GCF of sine of x, we're left with tangent of x minus 1. Now we can set both of the factors equal to 0 to solve. So sine of x is equal to 0, tangent of x minus 1 is equal to 0. And now we can take the steps to solve for x. So here, x would be the inverse sine of 0. So which angles would give us a sine value of 0? Those would be at 0 degrees and 180 degrees. Over here, tangent of x equals positive 1. So x would be the inverse tangent of 1. Which angles give us a tangent of positive 1? Well, that's going to be a 45-degree angle in the first quadrant, and then a 45-degree reference angle in the third, so 225. So all four of these are solutions to our original equation. Okay, again, because there was more than one trig function in the beginning, we had to rearrange and set it equal to 0 and then factor. So here you see two quick examples of how we're going to use these inverse functions to solve equations. Okay, so in number 2, we saw that we factored by taking out the GCF. In number 3, we're going to solve by factoring as well, but it's going to be of the form a squared plus, a squared plus a, oh my goodness, what am I doing? X squared. Ax squared plus bx plus c. You guys remember that, how we factor this sort of quadratic here? Notice in the directions that they do change the interval from degrees to radians. So we just need to pay attention that all of our answers here should be in radian form. So if we look at this quadratic, we have sine squared of x minus 2 sine of x plus 1. The variable here is the sine, right? So it's kind of like saying a squared minus 2a plus 1. If we wanted to factor this quadratic, this would be a minus 1 times a minus 1 equals 0, right? So if we follow that same form, instead of a is sine. So this is saying sine of x minus 1 times sine of x minus 1 equals 0. So since these are both the same, we only need to set that 1 equal to 0, and then we can solve. Sine of x is equal to 1, so x is the inverse sine of 1. So where is around the unit circle is our sine value 1? Well, it's at 90 degrees, or at pi over 2. So this quadratic happened to only have one solution at pi over 2. So you'll see, again, we had factoring by our GCF over here, normal factoring here. Okay, let's keep going. So here we saw the interval from 0 to 360. Here we saw the interval from 0 to 2 pi. Sometimes the directions may be vague. It'll say give your answer in the correct form. So you'll need to remember this, that if the variable is x, then your answer should be in terms of radians. If your variable is theta, then your answer should be in degrees. Okay, so I'm going to skip a couple of these. We'll do those in class tomorrow. I want to do just these 3 before we leave. All right, let's take a look at number 4. So here we want to isolate the tangent squared. There's only one term, so we can start moving things around to isolate tangent squared. So tangent squared of x is -3. To continue to isolate tangent, maybe we're thinking we need to take the square root of both sides to get rid of the squared. But do you guys see over here, we're taking the square root of a negative. We can't take the square root of a negative. If we kind of go backwards, if we rewind a second, we have a squared term equaling a -3. Can anything that's squared equal a negative? No, that's impossible. This is impossible. So there is no solution to this equation. No solution to this equation, because nothing squared plus 3, nothing positive plus 3 can equal 0. So watch out for those types of special cases where there's no solution, and we'll see an extraneous solution coming up in class. All right, so let's continue moving on, last 2. So here you'll see that the variable changed to theta. So now, according to what we wrote down, our answers can be in degrees. So let's take a look at number 5. Here we have 2 different trig functions, but it's written in factored form. So here, because we can use the zero product property, since these 2 multiplying together equals 0, then either this one has to be 0 or this one has to be 0. So we could say cotangent of theta equals root 3. So theta is the inverse cotangent of root 3. Now, if you remember your reciprocal properties, the inverse of cotangent, the reciprocal of that is inverse tan, and the reciprocal of root 3 is root 3 over 3. So these are equivalent expressions, so you can think of them in terms of their reciprocal function if that helps you. So what angle gives us a positive tangent value of root 3 over 3? Well, that theta is going to be at 30 degrees in the first quadrant and then 210 degrees in the third quadrant. We'll move on to the next factor. So if we isolate and move the root 3 over, divide by 2, we get sine of theta is equal to negative root 3 over 2. Again, I just set this factor, this expression equal to 0, and I isolated the sign. So now theta is equal to inverse sine of negative root 3 over 2. So what angle will give us a negative sine value of root 3 over 2? So sine is negative in the third and fourth quadrants. Sine of root 3 over 2 is a 60-degree reference angle, so that's going to be at 240 and 300 degrees. So we're able to solve for all four solutions here. Again, the original equation was already factored, so we just had to set the individual factors equal to 0. Awesome. Last one. Again, you guys remember you can pause the video at any point if you need to look back at something, and I encourage you to do that. So here are two different trig functions. Let's go ahead and set this equation equal to 0. So I'm going to move the cosecant over. So I have 2 sine of theta minus 1 minus cosecant of theta equals 0. So we have it equal to 0, but this side doesn't look like we can do much with it. In fact, this cosecant, if I rewrite it as its reciprocal, it's 1 over sine, which I don't really like having this variable in my denominator. So what can we do here? Well, one of the strategies we can apply here is that if we have a rational equation, we can multiply by the LCD to get rid of that denominator. So what if we multiply both sides by sine of theta? If we do that and distribute it to every single term, let's take a look at what happens. Sine of theta times 2 sine of theta is 2 sine squared. Sine times negative 1 is negative sine. And then sine times 1 over sine, the signs will cancel and we'll be left with negative 1 equals 0. So by multiplying through by the LCD, now we have this quadratic that we can factor. So again, just like we did before, 2 sine of theta plus 1 times sine of theta minus 1 is how this one would cancel, equals 0. Now we can set each of the factors equal to 0 to solve. So for this one, sine of theta would equal negative 1/2. This one, sine of theta would equal positive 1. And then we would just go through those last steps of solving for theta. So inverse sine is negative 1/2, which angles would give us a negative sine value of 1/2. So that's going to be 210 degrees, 330 degrees in the third and fourth quadrants, which angles would give us a sine value of 1. That's going to be up at 90 degrees. So here are the solutions to this equation. Okay. All right, guys, I hope that makes sense. We're going to finish up these examples in class tomorrow, and be sure to ask me any questions that you have. All right, we'll see you later.